Welcome to Tech Talks. I'm Holly Scott. Today I have the pleasure of chatting with Clay Nolan, the CEO of Collabs. Clay is a serial entrepreneur with a foundation in paramedicine and biomedical engineering. Thanks for joining today, Clay.
Thanks for having me, Holly.
Great to chat with you about this technology. It's fascinating. Perhaps you could share with us a bit about the foundation of Collabs and what brought you to this innovation.
Yeah, absolutely. So as you mentioned, my background was in paramedicine. I started my career as a paramedic and then actually went back to school later in life to study biomedical engineering. And it was this, perfect accumulation of events where I had obviously the experience in paramedicine, emergency medicine, and then was learning about, all these different technologies we could use. And at that same time, the American Heart Association was starting to publish a lot of the data on the effects of airway management and ventilation during cardiac arrest. And what they were saying is that ventilation and airway management were actually decreasing blood flow and outcomes during CPR. And there was this huge movement. There's like the chest compression only CPR where you stop ventilations completely. And then for trained providers, they actually reduced the number of ventilations and the emphasis on airway management. And I understood the reasonings behind it. But I also thought that, well, we can't just ignore ventilation and airway management during CPR. There has to be a better way. And so that was the genesis of the idea for Collabs. It was a way that reduced the level of training and the time it took to actually establish an airway, which is required to direct air towards the lungs and not the stomach. And then also one of the novelties was a ventilation technique that actually enhanced blood flow during CPR, so worked with chest compressions instead of against them. And I started this venture. I knew very little about what it took to be an entrepreneur, especially in the medical device space. And slowly but surely started telling people about the idea and getting people excited, and was able to start getting some real interest.
That's fascinating. And I grew up in a era where CPR, I have seen it change. And if I think about the lay person and what we were trained growing up, and that emphasis away from airway management and into chest compressions, and maybe we could just dumb this down for a minute. Let's say we're in the grocery store, right? And somebody falls out, right? And you want to call for help. You call for help. You go down and you check for breathing and responsiveness. Where in this process would Collabs technology slide in?
Yeah, so I'll tell you what the initial kind of beachhead market would be, and then what the plan for the future is, right? And so currently, what you do if you saw somebody witness cardiac arrest and you're a responder that's a bystander, so you don't have any of your equipment, you would just do chest compressions. Mm-hmm. And the idea with that is that you have enough oxygen in your blood to circulate for several minutes before that becomes the limiting factor on survival. So just focus on doing chest compressions. Then the paramedics would show up, and this would be our beachhead market. And what they want to do is they want to place an airway. The importance of an airway is it basically directs air to your lungs and not into your stomach. So when you breathe normally, right, you suck air into your lungs. And that means that air is going to go the path of least resistance, which is because it's a negative pressure, it's only going to go to your lungs. So your stomach doesn't normally inflate when you normally breathe. The problem is when someone's not breathing on their own and you're ventilating for them, you reverse the mechanism. You push air into their lungs. And what that means is that, yes, when you push air in, some of it will go to the lungs, but a lot of it will also go to the stomach. Inflate your stomach, you're going to aspirate, regurgitate, and it creates all sorts of problems. So what we need to do is we need to put an airway into the patient's mouth. Some of them go in the trachea, some of them go in the esophagus. But what this allows is basically we isolate the lungs from the stomach. So when we push air in, it only goes to the lungs. So that's the first thing the paramedics would do. The problem with that is that every airway currently on the market has some sort of downfall. If you try to place a tube in the trachea, it's extremely difficult, it's time consuming, and we misplace about 30% of our tubes, which could suffocate the patient if not corrected. Other airways that go into the esophagus and kind of fill this area right here and push pressure against have shown signs of decreasing blood flow to the brain because they push across your carotid vessels. So neither of the airways are ideal. They both have pros and cons. But then we come into the problem of, so that's the first thing a paramedic would do, is they'd place an airway. That's the first thing they're focused on. And the problem with that is they're distracted. They're so trained to get an airway that they don't actually get the background on why the patient went into cardiac arrest, or they're distracted with that.
Mm-hmm.
So then once they establish an airway, then it comes time to ventilate. And the problem with current ventilation techniques is that you use, again, positive pressure to push air into the lungs. Well, the way we were designed was that there was this beautiful synergy when we suck air in with bringing blood back from the venous and preloading the heart, so your next heart contraction, it has more effectivity. When you push air in, that actually has the opposite effect. It pushes on the heart, prevents blood from returning, and therefore the next heartbeat or chest compression is not as effective. And so our idea would, hey, could we actually ventilate? I'm getting ahead of myself. So what they would do is they would bag the patients in order to replenish the oxygen, remove CO2, but that ventilation is now decreasing blood flow. So it's this balance that they've been trying to figure out of what's the good balance. Then they'd be rushed to the ER. The care would actually kind of continue. Usually the emergency physician wouldn't change out the airway. They'd stick with the traditional ventilation technique. Hopefully the patient gets pulses back. It's only 10% of patients actually survive neurologically intact. It's still one of the largest killers in the US. So most patients won't even make it to the ICU. And it's a long road to recovery. So that's the traditional care. What we're hoping to do is our device would come in initially with the paramedics. They would place our tube, which doesn't have any of the downsides, and then our ventilation technique would actually work with chest compressions to increase blood flow. The hope is that eventually, kind of like the AED or the defibrillator moved into the AED, that we would, first, when I talk about the AED, it's the defibrillators, right? You'd see the emergency physicians that would shock the patients. And then 10 years after that technology came out, now we have AEDs on the walls that have simplified defibrillation to the point where a bystander could do it. But we have the same possibilities with our airway. So hopefully one day, in the not so distant future, there will be a Ventor unit on the wall next to the AED, so a bystander can actually use our ventilation technique, increase oxygen and blood flow as soon as the patient goes into cardiac arrest.
That would be such a huge leap from where we are right now, but it's so logical. You think about where we've been. In our lifetime, the AEDs have become on the shelves of grocery stores and sports complexes and gyms and such. And they literally tell you how to use them, right? When you turn them on.
And that's the beauty, right? It's all of these technologies coming together where, okay, now you have training where you could, pull up on your phone how to use an AED and train yourself on an AED. The AEDs can now talk to you, right? Some of the exciting technology is they have trained responders or an app where a trained responder can actually get notified if there's a cardiac arrest within a mile radius of them, and then it actually delegates who's supposed to do what. So one person will grab the AED, another person will go do that. So now you actually have trained professionals responding that actually aren't on duty because of the connected world we live in. So it's not that large of a leap to think that the Ventor could be easily integrated into all of this and increase the survival rates, because of the chain of survival is just getting so much more intelligent and so much more connected. So it's really, really exciting space and a good time to be here.
It is exciting. I have to ask, because I'm fascinated with people. That's the nature of our business, right? So as someone who was at the responsive, you were a first responder. You were in the line of it, and then you went into and studied engineering. That's an interesting transition into building a company to find the solution. And I will say a lot of people would say it's brave and ballsy, right? So I'm curious on what gave you the confidence that this was an entry point for you?
I'm gonna have two answers. I'm not as brave as So you look at a paramedic or engineer, and you compare it to a lot of people, like a lot of my colleagues and fellow CEOs or physicians or business majors. They had a lot more to lose. They had high stakes careers, and as a paramedic, I actually didn't have a lot to lose. And that personality by nature isn't risk adverse. And so I'd like to give myself credit for being braver than I am, but no, honestly, I didn't have much to lose. Where if I was a surgeon making a surgeon salary, then I would be a little more hesitant to jump on as an entrepreneur. That being said, as far as my background, paramedic, engineer, the way I like to say it is I knew just enough about everything to be scary. I knew just enough about medicine, just enough about engineering, very little about business, but you have to learn something on the fly. And then I think, the trademark tagline I'm putting on this, I knew just enough about everything to be scary, but not enough about the FDA to be scared. And so I didn't have the hesitancy that I was supposed to, really knowing what I'm getting into, right? And I think that's, such a truth about life. If you knew everything that you were up against when you started, you wouldn't start anything. You would dig yourself in a hole and hide there forever. And it's amazing. I mean, one of my philosophies in life is that life is about recovery. I mean, you're never given enough information before you make a decision to make the right one, so rarely in life. And it's, how do you adapt when you get more information and make the decisions you can, or give yourself the flexibility to make decisions later. So I've been lucky. I did get surrounded by really great people early on. I wasn't scared to share the idea, and I was able to team up with the dean of Cal Poly School of Engineering, the associate dean of Cal Poly School of Engineering, a gentleman by the name of Mike Loffer, who's been my mentor. He's done several medical device companies, taken several public. I mean, he's very well respected, and he's taught me everything I need to know. So I've been extremely fortunate just because I was willing to go out and share my idea, and get input from people early on.
That's a common theme with successful professionals of all kinds. And by the way, risk and risk aversion is all relative. You can it isn't related to a dollar sign. I see very risk averse people who may be commanding big salaries, but they hate what they do and they're afraid to make a change. And then
Exactly.
there's people who are having beans every day because they have something bigger that they're going after. So I commend you for doing it and bringing something like this so valuable into potential patients, because this is life-saving stuff. This is really, really interesting. From an engineering perspective, because you do have the medicine and the engineering foundation, what were some of the greatest challenges that you had to tackle in terms of designing and developing this product?
Yeah, it was two things. I was developing both a novel airway, and then I was developing a novel ventilation technique. And looking back, the way I should have done it is isolated one thing at a time and started trying to develop both at the same time. Because what I could have done, and we use the animal model to evaluate the effectivity of the ventilation technique and the airway, but I was always trying to do both. And what that would mean is I was always limited by, let's say, the airway and its ability to detect pressures, which then relates to how I'm able to use our novel ventilation technique. And so I couldn't, I'd start developing the airway, and then that would limit how well the research or the capabilities of getting data on the ventilation technique, and then vice versa. And so I think the fact that I was developing two novelties, but trying to test them both at the same time, made it extremely difficult and delayed the research. Where if I would have been as wise I am now, wiser, I would have just isolated one at a time and said, okay, the airway will get there, but I really need to focus on the ventilation technique. How can I create this, and test this using what's already out there? So I think that was one of the biggest hurdles. The other thing that I've learned is I did everything different. I mean, from the way the airway connects to the way we measure exhaled CO2, everything I did was really built around the user and the use case, and I didn't go with what was already on the shelf. And that's just a recipe for hard engineering, because you have to test everything, and there's no standard that you can really go to. I think it'll pay off dividends when we go to market, because this is a product designed for the market. It was something that I envisioned using when I was living on an ambulance. And so I'm hopeful it'll pay dividends, that this was a user-centric design compared to, hey, this is what everybody does and this is why they do it, so we just stick with it. But man, oh man, it's been a lot of work.
That is a lot of work. That's really going through. So how would this take you years? How long have you been incubating this idea?
Yeah. So I would say I've been actually working on the project full time for about 5 years now.
Hmm.
There was some gaps in there with fundraising.
Hmm.
We got extremely lucky with our first round of funding. And I pitched once to a strategic corporation. They saw this thing work in animals and they funded us. Then that company got rolled into another company that didn't do early stage investments, and I lost my funding. The problem was I didn't have at that point, I didn't have a funding network. Normally when you go out and pitch, you pitch angels and VCs and you build
Hmm.
this. I pitched once, I landed money, and I didn't really realize what it took to raise money. So I had to go back to working. I just had a young family at the time. I had to go back to living on the ambulance, working probably honestly 96 to 100 hours a week, just living on the ambulance to support my family. And you can't raise money like that. And so again, I had some amazing network of friends and community that came around me to go raise money, quit living on the ambulance, go make this happen. And so I was able to then to go raise off, closed our Series A, which was a VC led with support from the American Heart Association. And then since then, I've been able to continue the development of the company. But there was probably a 3-year gap there where no development happened because I underestimated how hard it was to raise money
Hmm.
because I was batting 1,000% just off my first off my one at bat. Another lesson learned is always raise money. always raise money.
Always be in that mode of pulling in giants around you, giants in the people, in terms of people who believe in you and who believe in your vision. You hit on something pretty important, especially for those entrepreneurs out there and engineers who you can have the most brilliant idea. If you don't have the ability or willingness to give of yourself and get that personal stake in you. Investors tell me time and time again that they believe in the person and the technology, and it's in that order. So I heard you say that you're willing to share, you're willing to generously to give. You gave a lot of information. You told people what you're working on. If you're constantly looking for the dark corner and for someone to come around and turn it on you, you rarely get the opportunity for someone to be generous and forthright themselves. So yeah, I've seen this be a pattern, and I just want to speak to it because, especially coming from where you're coming from, that could be meaningful for a lot of people listening.
Yeah, I think I couldn't agree more. I have been humbled by the generosity of people, both from their knowledge, their time, and their resources. And luckily, it's never come back to bite me. But overwhelmingly, my faith in humanity, and just especially in the med tech device space, I feel like most people are. It's a small world. And their reputations are more valuable than whatever silly little idea you have.
Mm-hmm.
And the other thing, it's a tough space. When I tell people of my idea, like, I dare you to steal it. Please take this burden from me because you have no clue what I just bit off. So I think it's a little both. What blew my mind when I came into the world of entrepreneurship is I found out that normally, so it's the way I saw it, was I saw a problem and then I created a solution specific for that problem, right? Mine was very a problem-driven solution, and hence why everything's unique about the device, because I just came at it with no real background. And what I found out moving forward is that, oh my goodness, most technologies actually start as a technology and then they go out looking for a problem. And that blew my mind. I mean, absolutely blew my mind when I learned of this, and it makes sense. I understand it, but really understanding, kind of tying this into what you just said, is the reason I'm so passionate about, and the reason I've been able to get support, is I'm passionate about the problem that we are solving and the technology that we're coming at. It's something that would have made my life better and patients' lives better that I could witness firsthand. And so I have that energy that's carried me through those tough times, and then also got people engaged in the project. Right. And so going out there and talking to entrepreneurs and scientists, you better believe in what you're doing, because that's going to be what drives you through the tough times, because sadly, I think there are going to be tough times for everybody who's developing a technology. I've never heard of someone who had it easy.
Mhm.
The second thing is make sure that your technology is actually solving a problem that you're passionate about, and really understand that problem from a user, in med tech, we call it the value proposition, but really understand it from a user standpoint, because ultimately that's who's going to be adopting your technology. So kind of my two tidbits.
Great points. Great points. And I would add on to that too, based on what you've shared, just to wrap it into the same comment, is ensure that you understand how that problem's being solved thoroughly today. If it's a gap, how is it, what's the workaround that's being done right now? And you saw the workaround being this time consuming, this taxing procedure the paramedics doing, and no real solution in the wings happening. Researching what's going on and understanding what the marketplace is looking at, because no one likes, to be kicked and surprised if they can avoid it, right?
Absolutely.
Yeah. So we're in clinicals now, and when do you see this potentially coming to market for us?
Yeah, so quick correction. We are starting our clinicals this coming probably late Q2 of this year. The clinical study will last about 18 months. And so if everything goes smoothly, shortly after that. So we have another about, I'd say another year and a half minimum before this comes to market. But the good news is, and we didn't really talk about it too much, but one of the largest hurdles collabs has faced is, how do you prove this works in the clinical setting? Cardiac arrest, you don't get the luxury of selecting your patients. You never know who's going to be your patient. The FDA really wanted to see this in out-of-hospital cardiac arrest, so we have to put this on ambulances. So I'll probably get 30 patients, and I'll have to train 35 users. That's not your typical clinical study. And then we can't even measure blood flow during CPR, out of the hospital for sure, even difficult in hospital. So how do you know your device is working? So one of our biggest hurdles has been designing a clinical study that will actually show the device works in a small number of patients in a time-efficient manner. So what's going to be exciting is we have a clinical study that we've designed that we're going to implement again Q2 of this coming up 2023. And we'll know the device works in human, which would be a first for a cardiac arrest resuscitation device in that small of a study coming out. So we're excited. I mean, we really think that's going to help drive market adoption along with our animal studies and the easy use of the device. But people tell me it just keeps getting harder. Even once you get it through the FDA, then you have to go get sales, and I'll be contacting you for sure, because that is an area that I will definitely lack expertise. I think I will have carried it far beyond my my bandwidth and or my skill set. So we'll be reaching out to you surely.
Oh, and I'll be here. I'll be here for sure. These are the build of the company and the build of the competencies is it's a road. It's a road that you're going down, and it's an incredibly valuable one. And the nice thing about the med tech industry versus sales of a widget is, all along the way you're proving clinical value, and you're proving, and you're actually subtly settling and pre-selling along the way, and getting the awareness and attention and such. So that the resuscitation piece and the study of it, and you were sharing with me a little bit before even we started, that is fascinating. I understand you're at one of the most prominent facilities for this research right now. Is that correct?
I am world-class facility. We're doing animal models. This is our IDE enabling animal study that I'm at right now. That's why I'm in gown, and I'm actually going to tell them I'm going to be in there in 5 minutes to finish up this next study. But really, I mean, it's amazing. I'm going to kind of pause here. This facility, what you're able to see, and the dedication they've put into allowing us to see what ventilation does during cardiac arrest has been incredible. One of the other things about resuscitation, it is a chain of survival. All these things have to come together, and it's really fun seeing all these different technologies accumulating, and the hope is that we'll reach a tipping point where it goes from 10% survival to 50% survival, just because of all these things happening. And you hope as your product's the one that is the tipping point, so all of a sudden you can show that, hey, look, we increased cardiac arrest by 5-fold. But it wouldn't be without all of these dedicated scientists and other technologies slowly pushing this forward. It's definitely a labor of love, and it's really, really, I'm so thankful. I would have no clue how to run one of these labs, or what the important factors to look at. And they have a team of experts here to kind of help me guide me through that. So that's fantastic.
Phenomenal. Phenomenal. So we've got a very exciting year plus with collabs coming up with all on your deck. What about industry-wide? And I know it's hard for you to look up from anything else, but are there any trends that are exciting for you to watch that you're kind of keeping an eye on right now?
Yeah, absolutely. I mean, this has to do, they're starting to do, it's called ECMO. And what they're doing is, ECMO was a technology they used in heart and lung procedures, where basically they put in these large bore catheters into your femoral vein and arteries. Usually it's a cardiologist doing this procedure, and they circulate and oxygenate your blood by basically bypassing your lungs and heart. And again, this was used for lung and heart transplants. They started using it for cardiac arrest patients once they got to the hospital. And what that means is now they can facilitate blood flow and gas exchange to the point where they can actually take the patient into the cath lab and reverse the cause of cardiac arrest. And the survival, if they get to the hospital with reasonable blood gases, basically high quality CPR, their chance of survival goes through the roof. So there's only a few dedicated hospitals that are doing this. They're still working out the protocols and patient inclusion criteria. But it's really exciting technology, and seeing that maybe go to the out of hospital settings, really exciting. It's allowed us to do this clinical study, which is really interesting. It's basically, before we'd have cardiac arrest patients going to all these different hospitals with the IRBs. Now they just get funneled to this ECMO facility, and increases survival, so we can get long-term follow-up. So that's something I think is fascinating. But there's so much. I mean, as far as different ways to defibrillate, tons of research into ventilation and airway management. I just think it's time for improvement. There hasn't been improvements in survival of cardiac arrest in the last 20 years, and I think we're going to be at a tipping point soon. And I said, hopefully, collabs is the technology that pushes it over the edge.
Well, I'm rooting for you, and I know that there's a lot of interest in this area in the industry, for sure. So I definitely know I'm not alone. So this has been, Clay, this has been great. I'm not going to keep you from the people who need you more than we do today, but I really appreciate you spending some time and discussing this. It's an incredible innovation, and I'm excited to see the progress.
Well, thank you so much for having us, Holly, and talking about collabs.
Thanks for joining us on Tech Talks. Until next time, I'm Holly Scott.